Hello, and welcome to a new chapter, number 25 of Azure Support Academy. In this episode number 5, we are going to talk about how to improve a bulk insert process.
My name is José Manuel Jurado. I am an escalation engineer working in Microsoft and subject matter expert in this technology.
Well, how it's possible to improve the bulk insert process? Well, basically, one of the key point will be the network. Okay, so for the reason, I would like to suggest if you have the chance to discuss with your colleagues from networking is to review the network devices bandwidth. Okay, it's very important, or to review, if could be possible, if you're using your machine, the application is using all network drives. So it's very important because normally all depends right now about the network speed. How is possible to improve the process? Well, we have several actions here. The first thing is to change the packet size. Packet size means that is amount of data that we are going to transfer using the Ethernet packets. Basically, the idea is to, if you have a huge amount of data to transmit, sometimes it's using increasing the packet size will be one option that you have, right? So if not, we could skip this one, but think about it. The other thing is to run in parallel. I think that is the most important thing. Instead to run just only one single process, the idea is to split for multiple process to run in this part, right? Other thing is you are using, if you are working in Azure, I think that is in order to speed the network bandwidth, or sorry, the network bandwidth and also the network speed, is to use accelerated networking. Review also the TCP performance tuning, because I think that also is a very good documentation about how to improve the connectivity. I think that logically download the necessary data in terms of amount of data, in terms of number of rows, in terms of number of or columns. Okay. In my examples, as we mentioned several times, if you are not using, try to disable Mars. Okay. One of the options that we have many cases about it is the round trips, network round trips. My recommendation is to use parametric queries. So what that means? That means that instead to send the text, suppose the following scenario: you have a bulk insert process, you are using insert into table columns values, and then this text needs to send the data from your application to SQL Azure. SQL Azure or SQL needs to obtain this data and say, okay, I received this data, I received the data, I received the data. And then you are sending beside the values, you are going to send, or you are sending the text insert into, and the end is too much round trip because you are sending too much data over the network. So the idea is to use parametric query instead to run just only insert into, just only send the parameter values. Okay, use this, you are going to see a huge improvement because you are going just only to send this value using prepare command. Other things is about review this article that we have about the behind the scenes of optimized for sequential key. This new option that we have is going to reduce a lot the contention that we have inserting data at the last page. Okay, so please review this one because I think that you are going to reduce a lot this part. Finally, is other things that I think I consider that is important. When you are adding a huge amount of data, SQL Server needs to update also the indexes, review the constraints, etc. So one thing that I saw is if I delete indexes, insert the data, and after I recreate indexes or build indexes, you are going to improve the process because there is no need during this process, there is no need to update the indexes. Basically, it's needed to update the data. So for the reason, one thing that I used to suggest is try to reduce the indexes. Other things is about the constraints. So when you are inserted the data, using the bulk insert and you have some constraint, let's say validate that this value doesn't exist, or connecting or check if the value is another table, etc. So it's very important to avoid this constraint during this process and after it run this constraint, right? So in this case, you are going to also to speed the process. And finally, about the statistics. So I saw several situations that when the customer insert a huge amount of data, they start running select commands. And they start facing some performance problem reading the data. Well, basically you need to think about two things. First is when you have statistics and when you are insert data, these statistics will not update it based on the distribution of the data. Okay, just only will be automatically, depending on the settings that you have in your database, we are going to update the data or update the statistic distribution of the data when you run the select, but just only using a small part of the data. So could be that the query will not execute in the best way because the distribution of the statistics is not updated. So in this part, if you have the chance, try to, after the insert process, try to update the statistics, if could be possible, also with full scan, in order to have the best distribution of the data. Because when you run the select will update, will use the best distribution of the data in order to run the query. Okay, so what is the purpose of the demo? Basically, I'm going to transfer the data from one table to another table, okay, using business critical database. You know that the business critical database in terms of I/O is we are going to use a low latency. Okay, it's very important when you are adding a huge amount of data to use at least premium business critical, or in this case, depending on the volume of the data, hyperscale. The table that I'm going to use will be demo. Demo contains 6 million of rows, around 40 bytes per row, and I have right now 195 columns. My goal is basically download the data as much as we can. Well, while we are running this bulk insert, the main idea is also to monitor how is going the process, right? So we are going to run three queries. The first query is to know what is the different weight stats. The second query that we have here will be about the performance counter. What is the counter basically about the network. Another one will be to know how many connections that we have in order to see the different threads, the different connections that they have running against SQL Server. Okay, let's get started. So right now, as I mentioned, the idea is to download the data from on-premises, from one database that we have in Azure. This database, as we mentioned, is business critical, and the idea is to download this around 6 million of rows with this amount of data, download the data directly to on-premises. So the first thing is, as we mentioned, is to run a select command. But if we run the select command, let's try to run. One second is here. Okay. So this is the speed that right now I'm downloading data using my internet connection, right? So as you can see here, just only using one thread, just only one query, I download the data every 10,000 rows. Right now it's taking more or less this time. It's downloading this number of bytes, approximately about the number of bytes that is downloading for every row, because this table has a lot of data, dummy data. They have around 195 columns. Right now, this is the amount of data, more or less, that I downloading as a total. It's an increment value that I downloaded data, and also I'm including the total amount of time that is taking this operation. So if I continue working with this, and the end is taking several times. So in order to measure what happened in terms of downloaded data, as you could see here, right now we are reaching 140 megabytes per second. In terms of load, I don't have too much CPU usage in this case. As you can see, it's not taking too much time. The memory is fine. The storage, it's fine in my case. And basically, it's just only the network that is taking this time. So in this case, I'm going to run in using the same query that we used previously about what happened with my query. So right now, as you can see, we have async network IO. You know that this is a typical message that we have when one application requests the query results over the network, but but the applications cannot process the return results fast enough. For example, this wait stat is complete normal. The idea is try to reduce this wait time. Okay, so it's very important to check the network if you are using the best approach. I don't have any other application that is impacting in the network, etc. So as you can see, it's running the process. Right now, also running the OS performance counter. You could see the wait types that I have right now, and also you could see here about the connection, the application, etc. So this is a time, but our customer in this case wants to improve this process, but because in order to return the 6 millions, it's taking right now to more than 2 minutes. Will take around 4 minutes. So one thing that we need to, when you have this type of cases, is to review how is the connectivity, right? So in this part, I used to review, for example, the packet size. So I'm going, for example, I'm going to stop the application right now. Okay, so I'm going to modify it for example, to modify the connections timeout. Sorry, the packet size right now from the default value, for example, using 16,000. So I'm going that if this packet size will improve the connectivity in order to have the results more quickly. So I'm going to run again my application. Right now, as you can see, we have in this connection, in this connection, we have 16,000 in the packet side. We are using pooling, we're using the best practice, but right now, as you can see here, right now it's taking, could take less time. So it seems that it's running more faster because right now, for example, just only in 20 seconds, we return around 1 million. So if I review also using the resource monitor my network, I could see more activity right now. And also, if I saw the transmission, right now I have 10 megabytes per second, more or less, in this part. So I could see that the data, but right now it seems that this process will take more time, even when I'm using right now this time. As you can see here, more or less, we are going to have a better improvement. So what is the impact when we are working with this type of situation that we need to improve? Beside that, to review the weight stats, if we need memory, etc. Is also to review using any network monitor in order to review what happened with my application. So, as you can see here, one thing that I have learned is when I click in my application right now, you could see that right now one thing that I saw is right now the minimum packet size that I'm using the MTU is using no more than 1,500 bytes in this part. So this is the maximum in terms that we could do. It's possible to change, but I'm not going to review this right now, but it seems that we are in the right process. Also, as you could see here, when we have a packet size, you could see that if I specify 16,000 bytes, I'm going to receive multiple packets, okay, for the same conversation, because in terms of Ethernet, I'm going to receive several packets, as you could see here in the continuation of the conversation. So reaching this point, at the end, we have the same situation. Right now, for around 4 millions of rows, it's taking 2 minutes. Right now, I download approximately one gigabyte of data, so it's taking time, right? So other things that I check, I thought that, okay, most probably I'm not using correctly the different objects that we have about the object about the SQL data reader. In this case, I'm using the sequential access. For me, I think that in my test, I saw several improvements using the sequential access because the data let's say it's retrieving more faster. Every time, in order to capture in my application, in order to capture how much is the data that I transmit, I'm using the statistics from the connectivity, from the object, from the connection object, in order to obtain the byte received and the connection time. Okay, so but again, it seems that I have. So in reaching this situation, the next idea was why not to try to split in different threads the data. So at this point, my main idea was at the moment that I'm running the application. 1 second. It's here. I know that right now I have this number of rows, but I'm using one thread. The idea is why not to split in different threads this number of rows. So what is the idea? The idea is try to include right now, for example, let's do it 1 second. It's, for example, by 2. I have 8 vCores. I'm going to increase by 2 the number of threads that I have. So the idea is using the same scenario with the same packet size, the same technology, etc. I'm going to run this process using 16 vCores. I'm going to run this one. As you can see, the 1 second. Yep. As you can see, the first difference. So when I choose 16 threads, you could see that right now I'm going to run the query about this table, but the idea is to split. The split, how it's the process. The idea is use the command offsets. Okay, in order to obtain, for example, right now the first thread will obtain the data from the row number 1 until the this number of rows. The next thread is going to retrieve the data from this number to this number. To this number, the third thread is doing the same, and so on. So, at the end, the idea is to split or to divide this number of rows by the number of these threads and try to run the process. So right now, as you could see here, you could see that right now the process is right now I'm running in multiple threads running at the same time. And we are going to see that right now, for example, in terms of memory, in terms of networking, I increase the number of megabytes per second. So because I have more than this value, so right now we have 200, we could reach 300 megabytes per second, etc. So, at the end, the idea is, as I mentioned before, is to split the load or the retrieving the data from multiple threads in order to have this data. Okay, so as you can see right now, I have 3 megabytes, 300 megabytes, etc. In this process. As you can see here, right now I have multiple connections against my database. This is the latency milliseconds of my query. Sorry, of my queries. Yes, of my queries. So, and if I run, one second, if I, for example, obtain what happened in terms of SQL, in terms of weight stats, as you can see here, right now I increase the async the where IO. Okay, we have multiple processes running using these queries. Right now it's using more CPU, using more IO in terms of networking, etc. So most probably right now several processes finishes this process, and right now I'm going to have all the data in a couple of minutes. So this is one thing that I saw, but also other way that I found that is very interesting is when we need to retrieve the data and insert the data in another database, let's say on premises, or let's say in another database. So the idea that I have is I'm going to save the data from the table demo against the table demo 1. So basically, I'm going to modify the code in order that to instruct that instead to retrieve the data, insert the data directly to SQL. So basically, I'm going to modify this parameter. It's true. And the idea is in order to, when this reader obtain all the rows, instead to show how much data I obtain, the idea is to insert the data against the demo 1. So basically, my lesson learned about the bulk insert was to use a correct batch size, try to avoid to have a huge transaction. The idea is to reduce the transaction as much as we can. Okay. Also use enable streaming and include the bulk copy timeout. So the idea is I'm going to run the process again. Right now, even for example, let's try to instead to use, for example, just only 16 because I'm going to include 24. So we are going to increase more threads or more concurrent process at the same time. So right now I have this one. So as you could see here, all this process is running. One second, is running in this way. So right now we have all the information. Right now we have less rows to transmit because we have more threads to transmit. Right now I'm inserting the data very quickly. So as you can see right now, this data is going to insert. So one second, let me to, yeah, one second. It seems that I forgot, one second here. So I forgot to clip the table with about the previous examples that I did testing this application. I'm going to run again. As I mentioned, I'm going to run with 24 threads. Right now it's connecting all this process. As you can see right now, it's inserting right now around 15,000 rows without issues. As you can see here right now, it's inserting the data. If we run right now the request that we have right now, we are going to see most probably two things. One will be a Signegur.io because right now we are inserting data, okay? And in another way, we are going to see the insert bulk, okay? So sometimes you could see a Signegur.io, or you could see when we run the inserts, most probably we are going to see other things about Payolage, we could see log writer, other things. Okay, so at the end, most probably this process right now is running in multiple threads. So in a couple of minutes, I'm going to have these 6 million of rows with around 4 gigas of data, more than this, even including the indexes updated in my database.
Okay, thank you so much for attending these sessions. If you have any questions, please send an email to gmjurado@microsoft.com.